to another lesson in MCV4U. Today we'll be talking about implicit differentiation. So an equation can be expressed either explicitly or implicitly. An explicit equation is one where the dependent variable, or y, is isolated. So if we look at these examples that we have, at the bottom we have y is equal to x squared plus 3x minus 8, y is equal to sine squared x, and y is equal to square root x plus 4. And here, an implicit equation. So an implicit equation does not have the dependent variable y isolated. So some examples are x minus 3x is equal to x squared minus y. Here, again, we could isolate for y. Here we have y squared minus x is equal to 4. X squared plus y squared is equal to 25. And x squared minus 2x plus y is equal to 0. So here, how do we differentiate something if it is not written explicitly? So far, everything that we've looked at in terms of derivatives are explicit equations. Again, we use a method now called implicit differentiation. So implicit differentiation is nothing more than a special example of the chain rule. When differentiating a variable in terms of a different variable, we must always remember to take out the inner derivative. So for example, here we differentiate 3x to the power 4 in terms of x, then d over dx is equal to 3 times 4x to the cube, which is equal to 12x cubed. So, but if we're differentiating in terms of differentiating 3y to the power 4 in terms of x, then d over dx is equal to 3y to the power of 4. So here, we derive 3 times 4y to the power of 3. So that's similar to what we were looking at in terms of 3x to the power of 4, but we also have to derive the inside. Here would be dy over dx. Or here, again, we can rewrite that. If we multiply the 3 times 4, we'll have 12y to the power of 3 dy over dx. So again, same concept as what we used in terms of chain rule. Again, the derivative of the outside times the derivative of the inside. Okay, so if we're using differentiating using implicit differentiation, there's a couple of rules to just consider here and a couple of steps we take. So again, the derivative of left side is equal to the derivative of the right side. So derivative of the left side is equal to the derivative of the right side. So the first step is to derive both sides of the equation. To determine the derivative in terms with the dependent variable, then use each chain rule, including dy over dx. So including dy over dx as the derivative of y. So anytime we are deriving for y, again, we have dy over dx. So an example, if we had y squared, the derivative of that would be 2y. And so that's the same thing that we're doing. Move the power down and then subtract 1 from the power. And we're multiplying by dy over dx. Last step here would be to isolate dy over dx. Okay, so let's look at this first example here. It says determine the derivative for the following implicit relations. So as we see here, again, the y value is not isolated, so then we know that it's an implicit relation. So again, we're going to derive the left side, and we're going to derive the right side. Left side and right side. So if we derive the left side, we have 2x plus 2 plus 6y. And now here, because we're deriving the y as well, we have our dy over dx, and the derivative of constant is equal to 0. And so what we want to do here is we want to move everything to the other side because we are trying to isolate for dy over dx. So isolate for dy over dx. And so here we have 6y dy over dx is equal to negative 2x minus 2. And here we see that the dy over dx is being multiplied by 6y. So we're going to divide both sides by 6y. Okay, so we're left with dy over dx is equal to negative 2x minus 2 over 6y. Here we can take out 2. So if we take out 2 from the top, left with negative x minus 1 over 6y. So here, the 2 and 6 can simplify. So we're left with dy over dx is equal to negative x minus 1 over y over 3y. Okay, so let's keep going. So this next question is x squared minus xy plus 4y is equal to 2. So here we see that, again, this xy here, they're multiplying for each other. So when we're deriving that, we're going to use the product rule. And if you recall the product rule, we'll just write this on the side. So xy, say x would be a, y would be b. That's equal to a prime b plus a b prime. So here, if we're going to derive that, we see that and a prime is just 1, and b would be y, plus a, which is just x, and b prime, which is dy over dx. Okay, so let's derive the rest of the equation. So here, x squared derives to 2x, and now we have y plus x dy over dx, which we found from using the product rule, plus 4 dy over dx is equal to 0. So here we'll distribute the negative into both the y and the x dy over dx. So here we're left with 2x minus y minus x dy over dx plus 4 dy over dx is equal to 0. So here, if we look at negative x dy over dx plus 4 dy over dx, we can factor out a negative dy over dx here. So here we have 2x minus y minus dy over dx. And that will leave us with x minus 4, and it's equal to 0. So now we're going to isolate, move everything over to one side, and isolate for dy over dx. So here we have, so move the dy over dx to the other side. So here we have 2x minus y is equal to dy over dx, x minus 4. Okay, so here, again, x minus 4 is multiplying to dy over dx. So we're going to divide both sides by x minus 4. And so here, we see that dy over dx is equal to 2x minus y over x minus 4 as our final answer. Okay, so now let's look at this example. It says determine the equation of the tangent to the curve 1 over x plus 1 over y is equal to 6 at x is equal to 1 over 4. So remember, the equation of the tangent means that we're finding y is equal to mx plus b. And again, the m value of the tangent, or the slope of the tangent, is equal to the derivative of y. And we know that the derivative of y is also dy over dx. Okay, so here we have this equation, y over x, 1 over x is equal to 1 over y is equal to 6. So should we write that? So 1 over x plus 1 over y is equal to 6. So let's convert this to negative exponents. So if we convert this to negative exponents, we'll have x to the power of negative 1 plus y to the power of negative 1 is equal to 6. And here we're going to differentiate. So for the first one, move the exponent down. So negative x, and then subtract 1 by n, which in this situation is negative 1, which gives us negative 2. And here we have minus y to the negative 2, and dy over dx is equal to 0. And here we know that it's at x is equal to 1 over 4. So let's sub it into the equation. So sub into initial equation to find y value. Okay, so if we look at that, to find the y value, here we have 1 over x plus 1 over y is equal to 6. And so 1 over 1 over 4 plus 1 over y is equal to 6. So here we have 4 plus 1 over y is equal to 6. And so therefore 1 over y is equal to 2, and y is equal to 1 over 2. So we know that here y is equal to 1 over 2, and we can sub that back now into our equation. So we have a point 1 over 4 and 1 over 2. And so sub that back into our differentiated equation. So here we have negative 1 over 4 to the power of negative 2 minus 1 over 2 to the power of negative 2 dy over dx is equal to 0. So remember, if you recall, if there's a negative exponent in a fraction, so a over b to the power of negative m, we can rewrite that as b over a to the power of m. And so if we rewrite that, we see here that we can rewrite it as negative 4 to the power of 2 minus 2 to the power of 2 times dy over dx is equal to 0. So here we get negative 16 minus 4 dy over dx is equal to 0. Negative 4 dy over dx is equal to 16, and we move it to the right side, and then isolate for dy over dx, so divide both sides by negative 4. So here we see that dy over dx is equal to 16 over negative 4, or negative 4. Okay, and so here dy over dx is negative 4, which means that that is the slope of the tangent. So here we have the slope of the tangent, and we need to sub it back into our equation, y is equal to mx plus b, to find the b value. So again, we have the point 1 over 4 and 1 over 2, and we know that the slope is equal to 4. So y is equal to 4x plus b, and then we're subbing those values. So here we have 1 over 2 is equal to 4 times 1 over 4 plus b. 1 over 2 is equal to 1. Oh, so negative 4. So here it's negative 4. Slope is negative 4. So 1 over 2 is equal to negative 4 times 1 over 4 plus b. 1 over 2 is equal to negative 1 plus b, and therefore b is equal to 3 over 2. And so b here is equal to 3 over 2, so our final equation, therefore, y is equal to negative 4x plus 3 over 2, and that's the equation of the tangent to the curve 1 over x plus 1 over y is equal to 6, at x is equal to 1 over 4.